Hello everyone. Today I'm excited to present a project that combines both creativity and practicality. It's called a two-wheel drive forklift for industry warehouse. Now forklifts might not sound very exciting at first, but they're actually super important in the world of manufacturing and storage. Our project is a smart solution to a common faced problem in warehouses and factories. It's about lifting and transporting medium weight goods in more efficient and safe way using a compact forklift that runs on just two wheels. By the end of this presentation, you'll see how even a small project like this can make a big difference in real life industrial operation. Introduction. Let me begin by explaining the basic ideas. In factories and industrial godowns, moving heavy materials is a daily job. Usually, this is done using large forklifts or cranes. But here's the catch. Many items don't actually need those giant machines. Items that weigh around 60 to 40 kilograms are too heavy for a single person to carry safely, but they're also not heavy enough to justify using massive cranes. This is where the problems start. Workers often end up doing things manually, which increases the risk of injuries, reduce efficiency, and makes the process slower. So we thought, why not design a smaller, smarter forklift that can handle just these medium weights? That's the problem we are solving. Project objective. Now let's talk about our goal. What exactly we are trying to achieve with this project? Our main objective was to create a forklift that is small, affordable, and efficient. It should be able to carry medium weight goods inside tight spaces like factory floors or storage aisle, but not just that. We also wanted it to be remote controlled. That way, workers wouldn't have to walk with it or manually operate it at close range. This added to both safety and comfort. Basically, we wanted to design a machine that reduces human effort, works smoothly in confined areas, and still delivers strong performance without being too bulky or expensive. Why two-wheel drive? You might be thinking, why did we choose a two-wheel drive system instead of four-wheel drive like regular forklift? Well, there's a good reason. Two-wheel drive systems are much easier to maneuver in small spaces. Since only two wheels are powered, the forklift can turn more quickly and sharply, which is perfect for narrow island warehouses. It also consumes less power, which means it's more energy efficient. Plus, the overall structure becomes lighter and simpler to build. Fewer moving parts means less maintenance and fewer chance of something going wrong. So overall, a two-wheel drive setup gives us the right mix of control, compactness, and efficiency for the kind of environment we are designing this forklift for. Mechanical design overview. Alright, now let's dive into how this forklift is actually built. Think of the forklift's body as a skeleton of a system. We created a sturdy frame that can handle both the movement and the weight of the goods. At the base, we have two wheels that are powered by motors. These are the drive wheels. On top of this, there is a platform or loading space where goods are placed. Then there is a handle positioned vertically, which can be used manually for support or steering when needed. The design is compact and minimal but very stable. It's built to be strong without being too heavy or complicated. Forklift mechanism. The heart of the forklift is its lifting mechanism, and ours is no different. We attach a special lifting structure to the front handle of the frame. This is a part that rises and lowers the good. We use two bent metal strips as side rails to guide the lift up and down in a straight line. Then we added a rotating chain system driven by a powerful motor. When the motor turns, it moves the chain, and the chain lifts the platform vertically. This way, the weight is evenly distributed and lifted without jerks. It's a mechanical solution that's both reliable and easy to repair if needed. Drive and lift motors. This slide is all about the engine of our machine. To make the forklift move, we installed two DC motors that powers the rear wheels. These motors can make the forklift go forward, backward, and even turn. Then, for the lifting action, we use a different motor, a high torque one. Torque means rotational force, so this motor has enough strength to lift the platform even with good placed on it. We also added bearings at various joints. Bearings reduce friction, which makes the movement smoother and prevents wear and tear. So the motors do the heavy work, and the bearings make sure that everything moves freely and efficiently. Remote control system. One of the coolest features of our forklift is that it does not have to be controlled manually all the time. We give it wireless remote control. This means you can operate the forklift either using the handle on the machine or using a remote controller from a distance of about 5 to 6 meters. Imagine being able to stand safely away from heavy loads and still move or lift them. It makes the system more flexible and lot safer, especially in busy environments where you don't want people getting close to the moving machinery. Wireless circuitry. Now you must be wondering, how does a remote control actually work? That's where the wireless security circuitry comes in. We installed a set of wireless modules on the forklift that can send and receive signals. When the user presses a button on the remote, the transmitter sends a command. The receiver on the forklift then imprints the signal and tells the motor what to do. move, stop, lift, or lower. It's like giving the forklift instruction without touching it. And because we have used good quality modules, the communication is quick and accurate, which means there are hardly any delay between pressing the button and seeing the action. Demonstration models. This is where theory turns into reality. We actually built a working prototype, a mini version of the final product. This model can lift weight between 10 and 20 kilograms, which is enough to show how the whole system works. Of course, the real version in a factory could be scaled up to lift more weight simply by using stronger motors and thicker frames. The point of the demo model is to prove that the design works, the system is balanced, and the control responds properly. It's like the first draft of a real industrial solution. Components used. Building this forklift wasn't possible without the right parts. We used mechanical components like wheel hubs, axles, shafts, and tires to create the structure. Then we added motors, bearings, chains, and sprockets for movement and lifting. We also used electrical items like wires, wireless circuit, and a remote controlled unit. All these parts were mounted on a strong frame and tightened with screws and fixtures. Each component played a specific role. Putting them together was like solving a puzzle. Everything had to just fit in right to make the system work. Develop prototype. Develop prototype. Here we show the actual prototype we built. You can see how all the components come together to form a working forklift. It's not just a design on paper, it's a real physical model. We tested it, made adjustments, and improved it until it worked the way we wanted. This prototype is a proof that our idea is not only practical but also doable within a student project setup. Advantages. So, what's so great about our forklift, you ask? Well, first of all, it's easy to assemble and even easier to operate. It's perfect for moving goods inside the warehouse without using big bulky machines. It saves time, reduces manual labor, and makes work safer for the people involved. It's also very cost effective. Big forklifts are expensive, but our model can do similar job at fraction of the cost, especially for medium weight goods. So overall, it's a smart tool for modern industrial needs. Conclusion. To wrap it all up, the two-wheel drive forklift is more than just a project. It's a real solution for real problems. It's compact, it's smart, and it's designed with both efficiency and safety in mind. The remote control feature makes it stand out, and its ability to operate in tight spaces makes it highly practical. By reducing the need for manual labor and improving logistics of good movement inside factories, it represents a small but meaningful step towards automation in industry. We hope this innovation can contribute to a safer and more efficient workplace for everyone. Thank you for your attention. I hope you have a clear understanding of